Welcome back to section 7.2. The next thing we're going to talk about is parallel and perpendicular lines. So parallel lines are lines that are on the same plane that never intersect. So when you look at them graphically, they're always going to have the same slope as each other. They kind of have that same rise over run pattern so that they don't cross. So I have an example here of two lines, AB and CD, that both have a slope of 1.5 or 3/2. And you'll see that those are parallel and they never intersect. Perpendicular lines are a little more interesting. Those are lines that intersect to form a right angle. And when you look at the slopes of those lines, they have opposite reciprocal slopes. So in the example that I have, the line AB and CD are perpendicular to each other. They form a right angle when they intersect. And AB has a slope of 1.5, or that's 3/2. So AB has a slope of 3/2. And the line CD, which is perpendicular to it, if you notice it has a negative slope, and it's negative 0.67, which is its rounding error a little bit of negative 2/3. It was rounding, and that rounds to, it's negative 0.6 repeating, and so that rounds to the negative 0.67 if it's rounding. And so what you notice is one's positive, one's negative. That's the opposite part. And reciprocals, what reciprocals look like is, it looks like you just switch the numerator and denominator around. Or if you want to think of it another way, if you multiply those slopes together, you'll get -1. Because the 3's will cancel, and the 2's will cancel, and you'll end up with 1/1. And it'll be negative because one's positive and one's negative. So that's what those look like. So let's do an example of writing those equations. So we are going to find the equation of a line that's passing through the point -8, 3. And we're going to use the same line, 2x minus 3y equals 10. And we're going to write one equation where it's parallel to that line and another equation where it's perpendicular. So when they say parallel and perpendicular, they're basically telling you about the slopes. So let's go ahead and find the slope of our line that they gave us, the 2x minus 3y equals 10, that line. So if I want to find the slope, what I'm going to do is get it into slope-intercept form so that I can find that slope value a little bit easier. So I'm going to subtract 2x from both sides, so negative 3y equals negative 2x plus 10. And then I'll divide everything by -3 just to get the y by itself. So negative 2 divided by negative 3 would be positive 2/3 x. And then 10 over negative 3 would be a negative 10/3. So now this equation, I went from standard form to slope-intercept form, and I did that specifically so I could find the slope. Okay, so the slope of the line that they gave us is 2/3. So in part A, where it says it's parallel to that line, it means it has the same slope. So I know that our line is also going to have a slope of 2/3. And I know that we are going through the point -8, 3. Okay? So whenever you start out with a point and a slope, I think that point-slope form is the easiest way to get started. Okay, so in that point-slope form, just reminding you all, that's y minus the y-coordinate equals slope times x minus the x-coordinate. And so using the information we have, we'll have y minus my y-coordinate, which is 3, equals the slope, which we just figured out, it will be 2/3. And then x minus the x-coordinate, well, it's minus a -8, which is the same thing as plus a positive 8. So that would be the point-slope form. It didn't tell us which format to put it in, so let's go ahead and get it into slope-intercept form. So that's a pretty common format. So what I'm going to do to get it into slope-intercept form is I will distribute the 2/3. So I'll do 2/3 times x, which is 2/3 x. Plus, if I do 2/3 times 8, that's 2/3 times 8/1, if you want to think of it as a fraction. So 2 times 8 would be 16, and 3 times 1 would be 3. Okay? And then the last thing to get it into slope-intercept form would be to add 3 to both sides. And if I'm looking ahead, I know I'm about to add it to a fraction, so let's go ahead and get the same denominator, which would be 3. So 3 would be the same thing as 9/3. I'm just multiplying by 3 over 3 to get there. So I'll have y equals, that would be 2/3 x, and then 16/3 plus 9/3 would be 25/3. And there we are into slope-intercept form. Okay. If you wanted to get it into standard form from here, you certainly could. We could subtract our 2/3 x from both sides and multiply everything by -3 to get it in standard form. I'm doing the 3 so that I don't have fractions, and I'm going to do the negative so that my leading coefficient is positive. So you can actually do them both in one step, which is pretty exciting. So that would be 2x minus 3y equals -25 if you want to get it into standard form. Okay, so that was fun. That's a very comprehensive way to do the parallel lines. In part B, we're doing perpendicular lines. So the nice thing is we did all this work to figure out the slope is 2/3. So I don't have to do all of that work again. I just can start from here. And so for my perpendicular line, my slope would be an opposite reciprocal slope. So the opposite of a positive would be a negative. And then the reciprocal, it looks like we're just switching the numerator and denominator. So the reciprocal of 2/3 would be 3/2. So for my perpendicular line, my slope is going to be -3/2. We're still going through the point -8,3. And so we're going to start the same way that we did in part A. We're going to start with our point slope form because we're given a point and a slope. And just refreshing you all, that's y minus the y coordinate equals slope times x minus the x coordinate. So for us, that would be y minus 3 equals our slope, which is -3/2, times x minus a -8, so that's really +8. So there's point slope form. If I want to get it into slope-intercept form, what I would do first is distribute. So -3/2 times x is -3/2 x. -3/2 times 8, so I would have -24/2, which would simplify to -12. And then I would add 3 to both sides just to get y by itself. So I'll have y equals -3/2 x, and then -12 plus 3 would be a -9. And now, ta-da, we are in slope-intercept form. Okay, if you want to get into standard form from here, you certainly can. We would add 3/2 x to both sides. So I'll have 3/2 x plus y equals, that would be a -9. And then we just don't want the fractions. The leading coefficient is already positive. So all I've got to do is multiply everything by 2. Just so that we don't have a fraction over here, we want just integers. The 2 times 3/2 would be 3x. We do need to distribute it to the y, so it would be 2 times y is 2y. And -9 times 2 would be -18. And that wasn't too terrible to get into standard form. Okay. So now that we've done a lot, I'm going to give you guys a chance. Now it'll be your turn to try one and show me how much you've learned.